we studied that everything around us is made up of matter. Now, can you tell me what the shape of matter is? For that, we must first know what matter actually is. Matter is in the form of water, plants, birds, humans, and everything around us. So how did scientists decide its physical properties? When we researched a little more on this topic, we realized that there were two different groups debating about the shape of matter. The two schools of thoughts were at loggerheads with each other. What was the issue after all? One school of thought considered matter to be continuous like a block of wood, while the other thought of matter as made up of particles like sand granules. Well, if matter is in the continuous form, it would be quite rigid, don't you think? And what if matter is in the form of particles? Yes, it would be very flexible. The latter assumed that matter was nothing but tiny little particles that can fit in anywhere, in any form, to give rise to varied shapes and structures. Let us do an experiment to understand this better. I have a beaker here filled with water. Mark the water level and let me add a spoonful of salt to this beaker. Now stir the solution for about a minute. Did the water level rise? No, it didn't. But we did add matter to the already existing matter of water, didn't we? Then why did the level of water not rise? Did the salt disappear? Well, it kind of did, but it found its new place inside the matter of water. Yes, you heard me right. The particles of salt moved about inside the spaces of the water particles. If matter was continuous, salt wouldn't have dissolved and it would have stayed in its own distinct form. Well, it didn't. So the second school of thought was right about matter being in the form of particles. Now what about the size of these particles? Can you see the size of the particles with your naked eyes? Have you ever seen the particles of water? No, we haven't, so we know that they're very minuscule. But how minuscule are they? We can take a guess at that with another experiment. Now let's take another beaker with water. Now add a couple of copper sulfate crystals to it. What happened to the water? It changed its color, right? How about adding some more water to it? Can you still see the color? Yes. Now let's add some more water. What we notice is that the color lightens, but it just doesn't seem to disappear. This means that just a few particles of copper sulfate can color a large volume of water. And it implies that there must be millions of tiny particles in one crystal of copper sulfate. They keep on dividing themselves into tinier particles, which proves that they are extremely small in size. Really, really small. So what were the two important things you just learnt? The first is that the matter is made up of particles, and second, they are extremely small in size. Let us study some more interesting facts about matter in our next video.